Hey everyone, and welcome back. It's great to have you here for another session from the Dr. Cool Cat team. Today we're jumping into forces in motion. Now, I know this is a topic on the GED Science test that can feel a little heavy, but I promise we're going to make it super straightforward.
Okay, so let's get right into it. You're going to see forces and motion pop up all over the GED. We're talking diagrams, little story problems, and yeah, especially those graphs. But here's the secret. You don't need to be some physics genius. The win here comes from getting really good with just one simple equation and a couple of graph rules. That's it.
And be honest, when you see terms like net force or a velocity time graph, does your brain kind of freeze up for a second? If it does, you're not alone, I promise. But what if I told you there's a simple system to cut right through all of that confusion? Well, that's exactly what we're going to do right now. In the next few minutes, we're going to build your personal no-panic toolkit. This is for any forces in motion question the GED decides to throw at you. So, let's get started. First things first, let's talk about the master key. This is the one thing that unlocks pretty much everything else. It all boils down to one single powerful equation. So, what are we even talking about? A force is literally just a push or a pull. That's it. The really important part is the net force. Think of it as the final score. It's what's left over after you combine all the different pushes and pulls. It's like a game of tug of war. The net force is what tells you which team is actually going to win and move the rope. And here it is. This is the big one. F net equals m times a. That's net force equals mass times acceleration. This little guy is your absolute best friend for the GED. Seriously, almost every single calculation question comes right back to this formula. You got to remember this one. This also helps us clear up something that trips a lot of people up, the difference between mass and weight. Look, mass is just how much stuff you're made of, and it never ever changes. Your mass is the same here on Earth as it is on the moon. Weight, though, that's the force of gravity pulling on all that stuff. And since the moon's gravity is way weaker, you'd weigh a whole lot less there. Okay, so knowing the formula is awesome, but how do we actually use it when things get complicated? Well, you need a game plan, a visual one. We do this with something called a free body diagram, or FBD for short. Don't let that fancy name fool you. It's just a super simple sketch. You draw a box for your object, and then you draw arrows pointing out from it for every single push or pull. It's the best way to get all your thoughts organized before you even think about grabbing a calculator.
And to make it even easier, we've got a strategy for you, the FORCE checklist. It works every time. First, you figure out all the forces. Then, you orient your directions. Decide right is positive and left is negative. Next, reduce all those forces down to a single net force. Calculate using our master key, F equals ma. And last, evaluate your answer. Does it make sense? Follow these steps and you're golden.
All right, let's put this thing to work with a classic GED-style question. So you've got a 4-kilogram box, there's a 14-Newton force pushing it to the right, and a 6-Newton force pushing it to the left. The big question is, what is the box's acceleration? Let's use our checklist. Okay, step 1. Find the net force. We've got 14 newtons to the right and 6 to the left. So they're fighting each other. 14 minus 6 gives us a net force of 8 newtons to the right. See? The box is definitely going to move to the right. Now we just rearrange our master key to solve for acceleration. A equals F net divided by m. We plug in the numbers, 8 newtons divided by 4 kilograms, and that gives us an acceleration of 2 meters per second squared, to the right. And just like that, you've got the answer.
Nice. Calculations are one half of the battle. The other half is understanding those motion graphs. Let's break these down so they're just as simple and panic-free.
Okay, when you see a position versus time graph, I want you to burn one word into your brain: slope. Seriously, on these graphs, the slope of the line tells you basically everything you need to know. It's all about the slope. So here are the rules. The slope of the line is the velocity. If you have a really steep line, it means the object is moving faster. And if you see a totally flat, horizontal line, well, that means its position isn't changing at all. So its velocity is 0. The object is just stopped. Now for the other kind of graph, the velocity versus time graph. These are a little different, a little more powerful. For these, you need to look at two things: the slope, just like before, but now you also have to pay attention to the area underneath the line. So on a velocity time graph, the slope tells you the acceleration. That's how fast the velocity is changing. And the area under the line? That tells you the total distance the object traveled. So Yeah, you can pull two really important pieces of information from just this one graph.
We've got the tools, we understand the graphs. Now let's talk about the test itself, because the GED test makers love to set little traps. But don't worry, here's how you're going to spot them a mile away and just walk right around them.
Here's your checklist for those tricky spots. If a question says an object is at rest, all that means is that the forces are balanced out. The net force is 0. Oh, and always convert grams to kilograms before you use F equals ma. They love that trick. Remember, if something's moving at a constant velocity, its acceleration is 0. Acceleration is a change in velocity, right? And please, always double-check the labels on the graph so you don't mix up the two types. Finally, remember that force and acceleration need a direction, like right or up.
All right, you've seen the concepts, you've got the master formula, the checklist, and you know the traps to avoid. I think you're ready. It's your turn to put this all together.
So here is your challenge. Picture a velocity time graph. An object's speed is dropping, going from 9 meters per second all the way down to 3 meters per second. And this whole change happens in just 2 seconds. Your mission is to find two things. What was the acceleration, and what was the total distance it traveled in that time? Go ahead and pause right here. Use those rules we just talked about for velocity time graphs. Figure out the slope to get the acceleration, and calculate the area to find the distance. Once you've got both answers, I want you to drop them in the comments below. Let's see what you come up with.
And there you have it. Whether you're working through that problem right now or just soaking all this in, you should feel great about this. You have literally just built a solid, dependable toolkit to walk into the GED and crush these questions. No more panic.
You did a fantastic job today. You've seen that even these tough-looking physics problems are really just about applying a few simple rules. You've got this. If this breakdown helped you out and made things clearer, do us a favor and hit that like button. And be sure to subscribe for more GDE guides from all of us here on the Dr. Cool Cat team. We'll see you in the next one.